All right. Got a long time to stream today. Super excited about that, and I want to make some progress. So let's get started. What we're going to start out by doing is just checking to see if changing the sample fraction fixes things. So I was using a sample fraction of 30% before. Now, in order to do this, we're going to have to make these sample masks. That's fine, but it's going to take a bit of time. Let's see if using a sample mask of 50% makes the thing work. Now, if I made a sample mask of 100%, that should definitely make it work. I think the code currently breaks because then the number of samples is 0. And the code assumes that the number of samples is greater than 0. But that's something we should fix. All right. So going through. We're checking all the checks. Those checks, of course, are amazingly helpful. Let's get past that. We've passed in an epsilon, and it's the noise variance. Okay, so now we're going to use PDHG to solve this problem. That looks decent. Now, before we saw a much better result, right? When we saw that, we were using sensitivity maps. And the issue you might remember is that when we use the sensitivity maps, the noise bound no longer is relevant. What is this? There's something going on in the mail. I don't know how mail popped up. Okay. I'm not sure why I stream or why I post to Twitter that I'm streaming or whatever. At one time, this was super fun. It's sort of helpful to talk things out while I'm doing it. Mostly, I just want a complete record of my development at this point. You see these blocky artifacts? That sucks. All right, that's with 60% sampling. What if we did 80% sampling? Or 50? That was 50. 20% reduction is not that much. Not useful, really. But let's just see if it works. At 80% sampling with compressed sensing, there should really be no artifacts, even with a single coil. That looks good, but there's still artifacts here. Maybe this, oh, wait, why does it go bright, dark, bright? That's strange, isn't it? Maybe these are just extreme wavelet artifacts here. Nice detail here. Lots of artifacts, though. Lots of wavelet artifacts. Is there a bug in this code? Who on earth knows? %60 undersampling. Okay. The artifacts are more severe. And look in here. Okay. That might be what it does. I don't know. Let's add in the support. Oh, before we do that, let's make this work with complete sampling. See here, this is going to be empty. Where does that get used? certainly gets used here. Let's see if it works with complete sampling when we pass in an epsilon. Okay. It's weird that it's bright, dark, bright. Is that different from it is. And maybe that's because I didn't run for enough iterations or something. Subtly different. Significantly different, actually. PDHG doesn't give us the perfect answer unless we run for an infinite number of iterations. And of course, there's an epsilon, like it's not enforcing hard data consistency. Now, of course, okay, what happens if we take that away? Then it's going to crash, I think. Right. Crashed for a very simple reason. X naught. Did I not supply X naught in this case? Looks like I did. N unknown. Right. Since X naught is empty, there's just nothing to solve for here. This is empty. So the image is F inverse times K data. That's what I hope I just implemented. Yep. Okay. With hard data consistency, everything, and 100% sampling, everything works fine. So this is all but one. I'm only going to solve for one value. The least significant value, or one of the least significant values. Okay, so with hard data consistency, it gets a very good image. This is very comparable to just the reconstructed image. Okay, this all seems to be working. Now let's add in the support. What is that error message? We're not going to do multiple coils yet. Maybe we will. Maybe that's the right answer. Okay. We're changing. We're going to multiple coils. Let's see what this does. It crashes. Oh, it doesn't even get there. Okay. Does that still work if we're just doing one coil? Does that check work? Yep, good. Okay. One last thing to do. So this is the one where I'm doing the giant A matrix that is psi MF, right? Concat psi MF. But now we know that psi is orthogonal. So let's get rid of that. So how are we going to do this? Apply A is equal to apply MF. F is equal to norm L2, L1 psi of X. Psi here I think is going to break. What is this? Okay, no, we've got it. We've got it. Okay. So what's the prox? Prox F is equal to prox L2, L1. Okay. Ooh, but you know what? Prox compose, composition affine, prox L2, L1 in psi 0, 1, T. And this needs to be, okay, G is equal to indicator function that. Can I do something like this in the case of hard data consistency? Okay, so I was clearly doing hard data consistency, but that's not what I want to do. Okay. Indicator function in zero epsilon. So it's not in, but it's apply mf to n minus b. Take the norm of that. Prox g project we're not doing apply mf because that's taken into account in A. Okay, so project onto the ball in minus b, let's not forget that one again. And what's the radius? NB times epsilon square root. Is there one that we haven't used PDHG yet? Hmm. What size is X naught? Seems like it should work, doesn't it? The logical indices contain a true value outside of the array bounds. How did that happen? No, of course it wouldn't work. Okay, so then what's the issue? Here, X are the images of all coils. Got a lot slower now because we're working with multi-coil data. We're at a sample fraction of 60% still. So each coil should look good. This will be interesting. Huh. What happened? K data is 256 by 256 by 8. Huh? Oh. So I use IM show scale? Okay, this is what we expected. What on earth happened? That's still there. Still there. Two checks all pass. I want to see all of these things operate. I don't need that one. Okay, in is 256 by 256 by 8. Okay, wait, what? Wave show. Why did that crash? Show image cube. Let's debug a fundamental function inside of dwarklib that I use all the time. So IMH did get show image cube is recursive. I didn't know that is positive. Okay. Oh, I see. Okay, yeah, that solved it. Put in that there. That's a wavelet transform, isn't it? Okay. That one seems to be operating on the right thing. In here is 256 by 256 by 8. Wave split. Okay. So that should have done a shrinking operation. Would have liked to have seen what size out is. Yeah. 256 by 256 by 8. I'd like to implement some dynamic stopping criteria for PDHG with line search. Okay. And are these all exactly 0? No, but they're pretty darn close. What happened? All right, let's step through PDHG. I got nothing left. Is there something like, how did I set up this problem? A is apply MF, good. F is the L2L1 of psi of n. Prox F is prox of L2L1 on in with the composition with a fine where psi is the linear transformation, B is 0, alpha is 1, and T is D. Okay. Indicator function. That was a bug, but I don't think that mattered for this problem. This is the same equivalence as up there. So here X is multiple images. What's with B? Is B 0? No? B is not 0 for any coil? Is it the prox of L201? No, we've already dealt with this. Wait. Norms in is 256 by 256 by 8. Right, in is 256. Norms in is 2. Okay, this is the issue here. I can rep map, but that allocates memory and that's slow. So this is the problem. We're only doing the shrinkage operation on like the first 256 by 256 slice of in. I wish there was like I wonder if BSX, okay, doc, BSX fun. Does it have like a isolate? Or are these functions all just, yeah, equal? That might do it. I think that's going to allocate memory though. Yeah, I don't think that's going to do what I want. I could do the other one. The other way of doing this problem, which we discussed in a video long ago, and now we have the need to take advantage of it. So out is equal to in. Put BSX fun at R divide in norms in BSX fun at times norms out. So that does the operation, but now out not is finite out equals 0. I think that does it. There should be some infinities, right? Oh, maybe norm's in isn't 0 anywhere yet. Yeah, it's not. Okay. So if this works, this series just popped up. If this works, this proximal operator of L2, then we fix two fundamental bugs in worklib. One is prox L2, and the other is show image cube. Okay, now we've got a matrix of things. And this crashes. Why did that crash? LSQR supplied function failed. What was the supplied function? Apply VS. Because I don't have S maps. So when you don't supply S maps, Recon Roamer finds the S maps using that very simple fast technique. I think this will finally work. That looks good. Okay, what changes if we supply S maps? I think the answer is just this. Nope. Nope, 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 nope. Oh, I forgot to supply S maps. Okay. It happened that fast. There's no difference. What happens if we reduce the sample fraction to some extreme amount? Not extreme, just reasonable amount. So we're going down to 30%. This is a version of parallel imaging with compressed sensing. It's going to be tough to combine SPIRiT regularization into this. Okay. Are these different? No. Lots of detail missing. I mean, lots of detail missing. Artifacts showing up. This is not good. The reason this is a bummer is that when we included the sensitivity maps, then it got a much better result. But this is totally parameter free. But the degradation is too much to be satisfied with this. Now what? Now, apply, do we have an apply MFS? Yep. MFS to image minus B, take the norm of that, squared divided by NB. Incompatible, oh, right. Times 10 to the negative 6, you say. Because here, I can make apply A equal to apply MFS epsilon S maps and then call all of this again. So this, all of this work we did up until this point was just a surrogate to find this error, epsilon S maps. I say we see what happens. I just doubled the runtime, of course. But you know what? X naught's equal to image. Shouldn't need, okay, so I'm not going to double the runtime. I'm going to make that 100. Why is that 1,000? Okay. Does proxg not get called? Why is proxg highlighted? Might be unused. Gotta call proxg conjugate. Maybe, I don't know. Would proxg conjugate have called this proxg or the other? I don't know. Either way, this is more clear. So I actually need 200 iterations. Let's find out, like how much, because all of that's just to find that epsilon S maps, right? How much does that change? I don't like it there. How much does that change based on like for going from 100 to 200 iterations? Let's find out. If it's anywhere close to 1 times 10 to the negative 6, we'll call it a day. I'd really like to implement some dynamic stopping criteria, but it's just a lot to do. Why did that fail? Index in position 3 exceeds array bounds. Index must not exceed 1. Oh, because now this is pretty tough, man. Okay. What is default psi multicoil? It's going to call this psi multicoil. Psi goes there. So psi multicoil just calls psi on every coil. And so now I've got both psi and psi multicoil at my disposal. But default psi will be the default psi. So I don't need to call this default psi single coil anymore. I could just call it default psi, replace all. Where does psi get used? V psi. So now psi input size. What is V psi? Okay, what is psi input size? Because here I want psi to just be for a single coil, right? But here I want to set the multi-coil version. Here again, I want the multi-coil version. Wait, this is for single coil. Pretty tough, man, pretty tough. I see. change it all back. Okay, that I still want. Okay. I'm going to have a single coil and a multi-coil. Of course, it'd be best if psi just operated on however many dimensions you gave it. Must operate on either a 2D image or a 3D array, a set of 2D images. Okay. Where is default psi? Multi-coil. So I'll make this default psi. And there will not be a default psi single coil. Does that work? Why is that way down there? V psi. So I do need this psi input size. Same. Oh. In. Okay. Now I can just call this on in. Don't need that anymore. Okay. Now vSci works on however much data you send into it. Lots and lots of changes. Let's check in those bug fixes in dwarklib real quick. The description takes more characters than the actual change. Fix a bug, so prox L2 L1 now works on a major bug. Okay. Maybe we should put this up here when we start creating these linear transformations. Where's psi? Oh, I see. Psi can be passed in. That's the issue. I see, that's the issue. So psi can be passed in. Okay, I want to do it the way that I was doing it before. No, I want to do it. Yeah, okay. I'm going to take all these things down here. I know that they like get created after they first appear, but I like having them down here with the create linear transformations comment. And this is like checking the inputs, right? NK data, we don't need it anymore. Guess not. Now hold up. So this, I don't want it to be call this slice index. Not slices in volume, but slices like through coils. Or not is the issue. I think this works. Let's find out. Let's see where things crash. We are here. And they crash long before I get there. Psi input size. SK data. This image. We should check both. Second check. Check, second check. Check, check second of VSVP Okay, it works. Oh, is ProxG always being set now? Is that the issue? That's fine. That's fine. Okay. It's at least running. Okay. Those look like images to me. It's amazing how fast that works. Okay. By the way, I feel like S should come before MFS. Yeah, should probably go right after S. Warm starting with PDHG probably doesn't work well because we're just initiating the primal variable, but the dual variable is not initiated well. There's a way to initiate the dual variable well, I suspect. And like I say, lots to do. Okay, so now this is doing MFS. This is doing this problem here. What is epsilon S maps? 7 times 10 to the negative 6, okay. That looks terrible. Whoa, I did image. I should have done Y. That looks terrible. But now it might be because I showed the wrong thing. Okay, let's make that image. Image. Okay. Figure. Item show scale. We're going to look at X naught. That was what we had before the new optimization. And now we're going to look at image. That's with the new. And that is significantly better. Like, look in here. That's doing a decent job. These artifacts are terrible. Look in here, this is all great. Okay, so that's at least doing better. With 30%. Recon SPIRiT reg. Where were we at? I thought there was a place where, okay, what if we supply lambda? Does lambda right now only works, I think, yeah. Lambda only works right now if we have multiple coils. equal to apply MFS, MF, and then apply A, apply A. If it's MF, then ATA, yeah, okay. Just, masks certain Fourier samples. If we come down here, so apply A, apply A. I think lambda now works with both single coil and multi-coil. I don't have any lambdas. All right, we're back on. Twitch is filled with spammers now. Okay. Now here's something. I don't see I do not see my compressed sensing recons. Maybe I never put them into worklib. I guess that must be what happened. Okay, I want to set lambda. We got this stellar result, you might remember, not that long ago, using lambda when we were doing SPIRiT regularization. Now, is that because we were doing SPIRiT regularization? Fista is so nice. When you can solve something with Fista, solve it with Fista. See, that is a super nice result, right? That's an amazing result. How does that compare to, besides being way faster, how does that compare to this? way, way better. Look how blurry that is compared to that. And how does that compare to just Roma reconstruction? They're different. One's not necessarily better. Like you can see striations in here in the Roma reconstruction that you cannot see. Okay, what if I set epsilon maps equal to 1D minus 3? Is it because the regularization variable is wrong? So there is an epsilon S maps that should give us the same result that we got from Vista, theoretically. There's theoretically an equivalent solution. You know what would be interesting? I wonder what epsilon S maps is if we solve the problem with Vista using lambda equal to 1. Let's do that. Epsilon S maps. Five times 10 to the negative 6. If we set epsilon S maps equal to that, oh, this is not very different from the epsilon S maps we previously estimated. Which is 7 times 10 to the negative 6, 5, 7. I don't think that's going to matter much. I don't really think it's going to change the quality of the image at all. Yeah. But that should have been the answer. So if we make this 10,000, 1,000. Look at that. That is a very nice result. That's what I want. I bet you I can even do better. So tough, man. All right. Is this doing some different sparsifying function or something? When lambda comes in, it's psi x. And we're actually doing v psi. Why v psi? Oh, because v psi gives us for the norm. When we're down here, the sparsifying transformation is what? Prox L2L1. Well, that's silly. It should be prox L1 complex. Please work. Please, please, please work. Psh. Okay. Oh, I just made it larger, didn't I? I think this is an infeasible problem. It's not helping. We're back. We're back to the situation where we're getting bad results no matter what we do. But again, there is theoretically a epsilon S maps that should give us the same result as that Vista result. This should be L1. V psi, huh? I don't think that'll change the result. But at least let's fix the bugs when we can find them. So all the testing we've been doing, we have to redo it because I put a bug in the code. That's really bad. It's like looking. It's a completely different image. They're the same. Changing from 1 times 10 to the negative 6 to 1 times 10 to the negative 9 does nothing. What about 1 times 10 to 5 times 10 to the negative like 18? epsilon S maps is not changing anything. Okay, let's see. Well, after the projection, this is supposed to be less than or equal to that. And it's not. So what is this? 0.9. Okay, this is now the right size. It doesn't look like the problem's in projection. Okay. And what was happening before? Wow. Okay, the projection is doing what it's supposed to do. I have this ability to pass in metrics into PDHG with line search. Metric function, metric 1 is equal to let's take the maximum the difference between this and this. Difference between this and this. Okay. Let's do this one after the projection. That divided minus that. Metric 2 is equal to, let's call that metric 2. Metric 1 is equal to F. Metric names is equal to sparsity violation metrics is equal to metric 1, metric 2. All right. Let's see what happens there. So now I'm calculating these metrics and reporting them. And so the sparsity is not changing much, and the constraint violation is going down, but it's nowhere near 0. Okay, that's interesting. So we're nowhere near satisfying the constraint yet. I'm going to run this for 10,000 iterations. Sparsity is actually going up right now as PDHG is satisfying the constraint better. I'd only expect the sparsity to start going down after the constraint has been satisfied to a good degree. This is taking a long time. We know this problem is feasible because Vista gives us an answer that satisfies this constraint with these sensitivity maps. At 300 iterations, which is how long it's taking to get this far, we're only set the constraint violation is still only 0.16. It might take 10,000 iterations to solve this problem. And we're only at 500 right now. 430. We're storing these constraint values so we can plot them when we're done. Okay, the constraint's now down to below 0.1. That's a good step. Things aren't changing much anymore. They're certainly not changing quickly. So this was clearly a good idea, plotting these metrics. It's already almost 10 a.m. We've been doing this for what? 2.5 hours. Time flies when I engineer. Okay, so now the violation is down below 0.05. I wouldn't say we're meeting it yet, and the sparsity is still going up, it seems. I wonder if we're going to need 100,000 iterations. Can this be parallelized? This is vectorized. Doesn't look like it. Sparsity is now almost at 1. It'd be interesting to see the sparsity that's achieved with the FISTA result. I wonder how sparse it is. Sparsity is still going up. Violation still going down. I don't like the name violation. Need to take another break. All right. Currently, the sparsity is at 3,000. Sorry, the iteration about 3,000. The sparsity is at 1.02, and the violation is at about 0.002. Things are not changing a lot. Let's see how much this changes. Between now and 10,000 iterations. I wonder if it's going to look any better. Okay. PDHG with line search is slow. And that's a bummer. Is this a Lipschitz function? There's something about PDHG and Lipschitz. In practical applications like computerized tomography, it's often computationally favorable to replace the adjoint by a computationally more efficient approximation. This leads to an adjoint mismatch. That looks like an interesting paper. I guess I'll send that to myself. But that's not what I was doing right now. This is Shamble-Pock. Is there an algorithm too? In that case, one can show that the gradient of the conjugate is 1 over gamma Lipschitz. So the dual, what does it mean to be uniformly convex? Function. Uniformly. The function evaluated at the mean point is less than or equal to the mean value of the function evaluated at both points minus delta. So I think a constant function is not uniformly convex, right? Because then this value would equal this. So it wouldn't be less than delta. Is that what they mean by uniformly convex? So in the case the function is uniformly convex, it's Lipschitz. Now, did we just need Lipschitz? Like, is uniformly convex? No, I guess it's uniformly convex implies Lipschitz. Is the converse true? I'm guessing not. I don't know. Is the L1 function uniformly convex? Is the L1 norm? The L1 function is not uniformly convex, right? Okay. Because I think that, again, the mean value equals the mean of the values. The function evaluated at the mean value of the domain equals the mean value of the functions evaluated at the edges of that little domain. How are we doing? We're down to less than 0.001. I wonder if this is working. We're only halfway there. What is a Lipschitz function? Is the L1 norm Lipschitz? I think it is. Show that every L norm is a 1 Lipschitz function, right? So we have Lipschitz. What happens if we do this when we have Lipschitz, but we don't have uniform convexity? I'll bet you we don't get 1 over k squared convergence. That would be my guess. Is the Huber penalty uniformly convex? The answer is, of course, no. Yes, within a certain neighborhood, right? but the answer is no. To be uniformly convex means uniform convexity everywhere. And since it's only uniformly convex near the minimum point, it's not uniformly convex. Ooh, the violation is down to 1 times, or 6 times 10 to the negative 5 or so. That's getting small. That is getting small. And we're at about 5,000 iterations. The sparsity doesn't seem to be decreasing, not in any noticeable way, because we only got 3 digits of precision. I wonder what more digits will show us, but it doesn't really matter. I'm hungry. My other work is beckoning me. We're continuing to get closer. The violation is, the constraint violation is getting smaller and smaller. Now we're down to about 3 times 10 to the negative 5. It'll be very interesting to see what this comes up with. Depending upon what it comes up with, maybe preconditioning would help. And I've now got preconditioning possible in PDHG with line search. Okay, so in the first 100 iterations, we were nowhere near satisfying the constraint. I don't know that I implemented preconditioning correctly. I'll have to check at some point. The sparsity is still at 1.026. So the constraint violation is changing, but the sparsity is really not. These two things represent different parts of the objective function. Frank Ong has this preconditioning, what is that? SigPi? This is FISTA and this is proposed. I mean, that's not a great image at the end unless it's like some contrast that I'm unaware of. PDHG with proposed preconditioning. Okay, preconditioning helps. I wonder what his proposed preconditioning is. This is yet another paper I'm going to have to read. PDHG with case-based preconditions. That looks pretty good. Actually, does it look different? I don't know. Gonna have to read that. We're now at 7,000 iterations and we're down below 1 times 10 to the negative 5. We're at a constraint violation of 5 times 10 to the negative 6. What to-do items do I have up here? None? Oh, okay. Well, everything's to done then. Because, man, this is slow. If I could get a good result in like 100 iterations, that would be very useful. The only preconditioner I have right now in PDHG with line search is diagonal, I think. Oh no, I could supply any invertible one. I don't know. I think it's very, the only thing I've even pretended to try this with is diagonal preconditioning. Yeah. After I started running this, I thought maybe I should have just printed out like every 50 or something. But I thought it would take more time to make that change than run again at the point I thought of it. And now here we are, and I'm wondering if I should have just done it way back when. Definitely not going to do it now. We're almost to 8,000 iterations. We only got 2,000 to go. And we're at a constraint violation of about 1.1 times 10 to the negative 6, or 2 times 10 to the negative 6. Okay, I think it was clearly the case that I wasn't running for nearly enough iterations. And I like having this more informative print statement on the screen. If this doesn't work, I am out of ideas for now, at least. If it does work, boy, oh boy, I can't test running at 10,000 iterations. I'd never be able to debug anything. Gonna have to figure something out. The constraint violation is below 1 times 10 to the negative 6 now. It just keeps getting better. The constraint violation does. No. This is getting on the order of numerical precision or something. At least for floats. Wish I could operate with floats. I also wish this was all in C and that I could display stuff. It's kind of tough to display stuff in C. We're at 8,500 iterations now. If this works, I think the next thing I got to do is add in preconditioning. I'm going to read Frank Ong's paper, and I'm going to read Shamble and Pak, I believe, also have a paper on preconditioning for PDHG. And I'm going to read, and I'm going to try diagonal preconditioning, and we'll see where all that ends up. Douglas-Ratchford is another optimization algorithm. Here it is in Vandenberg's notes. Vandenberg is a supremely good note writer. Here it is. No conjugates, just straight proximal operators. You could express Douglas Ratchford as a averaged operator iteration, and that has a line search. Because I think there's like here's different forms. Yeah, and then there's this scaling. So I think you can do a line search over that parameter, though it may not be that one. Or with relaxation, no, you could do a line search over this parameter. But it's in the primal dual formulation, I believe. I'm not sure about that, but I think it is. In which case we do have proxy conjugate. Either way, this doesn't work for us because we can't put a matrix in front of those in that X. So that sucks. We're at 9,400 iterations. This is the moment of truth. Surely this thing will stop, right? $9,600. $97. We'll be done soon. Constraint violation is down to almost 1 times 10 to the negative 7. It looks like about where we're going to end up. I wanted to do preconditioning like after this research project. Looks like it's going to be forced on me. I wonder what the dynamic stopping criteria would be. The objective value is infinity. Glad I put that breakpoint there. It's terrible. All of that, and it's terrible. Okay. Let me look. Well, I think this is where we're going to end up today. And so, got a lot of things to think about and work on. None of this is spirit regularization. Looks like it's becoming a more and more interesting project. I'll see you guys later.